Hey, AP Stat students, today we are going to learn about how to find the expected value and standard deviation of a probability distribution. We're going to talk a little bit more about probability distributions in general as well. So we're going to start off with a couple definitions. We're going to talk about a probability distribution of a random variable. And what is a random variable? A random variable takes numerical values that describe the outcomes of some chance process. Okay. What is a probability distribution? Well, a probability distribution of a random variable gives its possible values and their probabilities. Here is a distribution of a random variable. Suppose the random variable G equals the number of goals in a randomly selected high school soccer game. G has the following probability distribution: 0, 1, 2, 3, and 4, with the probabilities associated with it right under there. Part A says show that the probability distribution for X, it should say G, I changed the problem, is legitimate. Well, in order to prove that something is a legitimate probability distribution, we have talked about that already. The first thing that we need to do is we need to check that 0.155 plus 0.195 plus 0.243 plus 0.233 plus 0.174 adds up to 1. And I'm going to go ahead without using my calculator and assume that it does. So we're going to say 1, the sum of the probabilities, in the probability distribution equals 1, okay? And then second, this is saying that each individual probability has to be between 0 and 1 in the probability distribution, and that is true as well. Okay, good. When asked, do you have to, or is it a legitimate probability distribution? Again, just double check. Do the probabilities add up to 1, 2, or each probability between 0 and 1? Each individual probability. Okay, make a histogram of the probability distribution. Describe what you see. When you make a histogram of the probability distribution, you're going to have your y-axis, your x-axis. On the y-axis, you are going to put the probabilities. So I'm going to put the probability of G. And then on the x-axis, we're going to talk about what that random variable is, and that is goals, G. Okay. When we're looking at it, we can go 0, 1, 2, 3, 4. So 0, 1, 2, 3, and 4, trying to have them equally spaced out apart. And then we're looking at now the probability. So my minimum probability here looks about 0.15, and my maximum is about 0.24. I'm going to go by 5s when I scale it. So 0.05, 10, 15, 20, 25. Again, just look at your min and your max. If you need help deciding how you should scale, just let me know. Okay, so for 0 goals, there's a 15.5% chance of that happening. So I'm going to make my bar approximating where that should go. Up, whoa, that was bad. Over and down. Okay. For 1 goal, we have a 19.5% chance of that happening. Okay. So the thing about this, guys, it's a histogram. So we do want these to touch. So 1 is going to go from here to about here. Okay. So I go up to about where 19.5 is, again, estimating there, over and down. 2 goals is about a 24.3 chance of happening. So 24.3, again, we'll go from here to about here. Again, histogram, the bars do touch. So I'm going to go up, over, and down. For 3 goals, let's see where are we at. 3 goals, we're at a 23.3% chance, so just a little bit below. Up, over, down. Again, we're estimating here. And then finally, 4 goals is a 17.4% chance of happening. So again, approximately where that should go. Okay, anytime you're asked to describe a histogram, you want to think about socks, shape, anything outliers, anything unusual, center, and spread. Again, we always want this in context, right? So what would I write? I'm going to write it up here actually, just because there's a little more room. The distribution of number of goals scored in the soccer game is symmetric with nothing unusual. The mean appears to be about 2, and the spread, we're going to use the range right now, is 4. Where are we going to use the range? Well, typically we would use the standard deviation, but we don't know the standard deviation right now, so I'm estimating that. And then the center, I put EX here. That's actually the expected value, and the expected value is the mean. When we have a probability distribution, we want to talk about the center as what that expected value is. That is the mean of the distribution. I'm going to teach you how to find that in a second. Right now, I just estimated it at about 2. Why did I estimate it about 2? Well, it's pretty symmetric. So it looks like that center is about 2. Again, we'll confirm that here in a second. So making a histogram, what do we need to know? Just a quick recap. The actual variables on the x-axis, the probability is on the y. It's a histogram, so the bars touch. We talked about the scale and how to describe it. Shape, outliers, the center. We will start to use the expected value. I'll show you how to do that, but for now we estimated what that mean was. We will start to use for the spread, the standard deviation. We don't know that yet right now, so we just talked about it as the range, which is okay to do. All right, so I had to change this real quick because this used to be about a hockey team, and we had up to 9 goals, and it was just too tedious to do. So I thought the soccer goals up to 4 was a little bit better. So, and this one is just, what's the probability that the number of goals scored is going to be at least 3? What does it mean to be at least 3? Well, if I look up here, where am I at least 3? I'm at least 3 with 3 goals here and then 4 goals here. So I'm going to add those 2 together. That would be the probability that the number of goals scored is 3, or the probability that the number of goals scored is 4. Okay. Again, at least 3 is 3 or 4. So I'm going to go ahead and I'm going to add those 2 numbers up. That is 0.233 plus 0.174. And that's going to give us what? 0.407, it looks like. All right, if I did my math in my head correct, I'll just double check for you. Yes, 0.407. So there's a 40.7% chance based on this distribution of the team scoring at least 3 goals. Okay, let's move on. Okay, so now on this slide, this is where we're gonna actually compute the expected value as well as the standard deviation of the probability distribution. Okay, so we have this random variable g. It says x again because I changed the problem, so forgive me. So it says compute the mean in a random variable g, and compute the mean of the random variable g, and interpret this value in context. Whenever we have a probability distribution and we're trying to find the mean is what we call the expected value. So those are synonymous. When they say, how much will you expect based on that probability distribution, they're talking about the expected value, the mean, the average. How do I know how to figure out that expected value? Well, they do give you this formula, and this formula is on your formula sheet. At some point, we need to get this printed for you if you don't have a printer, so please let me know if you don't have a printer. Okay, now on this formula sheet, you can see right here at the probability distribution, a discrete random variable x, the mean, and they give you this formula right here, which we have written right here as well. What does this mean over here? I'm going to cover it up so we don't spoil too much. Come on. All right. So to find the mean, this right here means we're going to find the sum. Okay. This right here, this xi, this represents an observation. Okay. What are my observations? My observations are my goals right here. I'm going to take the sum of the observation times the probability of that observation. You are expected to show your work for this. Let me show you what that's going to look like. Oh, come on. I want to get a different color. Oh, well, we'll have to live. Okay. The expected value is equal to our first observation. Our first observation is 0 times the probability of that observation, 0.155. It's the sum of the observation times the probability of that observation. So we have another observation. So plus 1 times the probability of that observation, 1.95. We have another observation, 2, right here, okay? Times the probability of that observation. Again, another observation, 3, times the probability of that observation. Finally, our last observation, 4, times the probability of that observation. Oops. Okay, that's how we show our work for what the expected value is. That's the mean of the distribution. Now, we can type this into our calculator manually. I can go ahead and I can figure out the product of each of these right here and add them up. But we're going to have to figure out the standard deviation too, and you're going to want your graphing calculator for that. So I'm going to show you right now how to do this in your graphing calculator. What I want to do right now is I want to put the number of goals into my list editor. So I'm going to go to Stats. I'm going to hit Edit on Enter. I'm going to clear out my L1, which I have right now. And I'm going to clear out my L2 actually as well. I know my number of goals go from 0 to 4. Okay, so I'm going to go to L1. L1 is going to be whatever the random variable is. 0, 1, 2, 3, 4. Okay, so now what we want to do in our L2 is we want to put the probabilities over in L2. Okay, so I have 0.155 for the first probability, 0.195 for the second probability, 0.243 for the third probability, and I can see that I typed that in wrong, so I'm going to redo that. 0.233 for the third probability, or fourth probability we're actually on, and then 0.174 for that last probability. It's always good to just quickly double check what's going on, okay? 0 through 4 is okay. We have 0.155, 0.195, 0.243, 0.233, and 0.174. We did that okay. All right, ladies and gentlemen, now what we want to do is we want to calculate the mean based off this probability distribution. So I'm now going to hit Stat. I'm going to arrow over to Calc. I'm going to hit Enter on one variable, Stats. For those of you with the old calculator, you're going to just see one of our stats right now. You need to hit second 1 so you can see L1. Old calculator people, you then want to hit the comma. So right now what you see, one of our stats, second 1 for L1, comma, and then you need, for everyone else working with me, you need L2. So second 2. We're going to go to Calculate now. And we can see right here, I'm going to drag my screen over with my fanciness. Ooh, baby. There, that's better. Right here, this X bar, that's the mean of our distribution. And remember, we estimated that it was going to be around 2, looking at our histogram, 2.076. And then you'll notice the SX is gone. This sigma X right here, this is the standard deviation of our distribution, which we need here in 1 second. Before we get to that though, we need to know how to interpret the mean. When you're interpreting the mean, you're always going to use this sentence frame. In the long run, we would expect the average number of goals to be, or the number of goals scored in a soccer game to be an average of about 2.076 goals. So let's type that out right now. In the long run, we would expect the number of, the number of goals to be scored in a soccer game to be an average of about 2.076 goals, okay? Again, in context, using that word average, talking about the word about. It's gonna be about or approximately. Okay, what should we get? Know how to find that expected value, taking and showing that work, showing each observation times the probability of that observation, and then adding it up, knowing how to type it into our calculator, and finally knowing how to interpret it. Last thing that we need to do for this video is we need to know how to find the standard deviation. If you look at the formula sheet, you guys, the standard deviation for the discrete random variable that we have is right here. This is the formula. I have it already copied over. Now we need to know, how are we going to interpret this? What does this mean? Again, we're going to find the square root of the sum. Well, what are we going to find the sum of? This right here is the observation minus the mean of the distribution. That's our expected value, which we just found. We take the difference and we square it, and then we multiply it by the probability of the observation. You do need to show your work on this, guys, to get credit on the AP test. If you just give them an answer, you will not get full credit. Okay, so let's go ahead and let's figure that out. The standard deviation is equal to the square root. Now I'm going to start typing so it looks nicer. Okay, so we're going to take the first observation. The first observation is 0. Minus the mean of the standard deviation, or mean of the distribution. The expected value, 2.076. We're going to square it, and then we're going to multiply it by the probability of that distribution. So the probability of that observation. So that's 0.155. And what I'm going to do is I'm going to go to the pen so I don't have to mess with that caret top, so squared. So we did, again, observation minus the expected value squared times the probability of that observation. We're going to go ahead and we're going to add now, again, next observation. The next observation we have is 1 goal. So 1 minus 2.076. Oh, why is it doing that? Come on, technology, work with me. We will square it, and then we're going to multiply it by the probability of that observation. The observation we're working with is 1. The probability of that is 0.195. Plus, I'm going to just try to use my mouse from here on out. The typing is messing me up a little bit. The next observation is 2 minus the mean, the expected value, 2.076, squared times the probability of that observation. So that's 0.243. We're going to keep going, right? Plus 3 minus 2.076. I'm going to try to squeeze it all in here, guys. You think I can do it? Squared times the probability of that observation. So that's 0.233. Oh no, this looks bad, but we're going to keep going. Let me move this down. There we go. Much better, right? Okay. And then plus, finally, observation 4 minus the mean, 2.076, squared times the probability of that observation, 4.174. Now, you don't have to calculate this by hand. Your calculator did it for you, the sigma right here. So sigma is equal to 1.3184. This is our standard deviation. What did we do here to calculate? Again, we took that observation minus the expected value, squared it, times the probability of that observation. Then we added it to the next one, and we keep on going. The last thing I want to do, you guys, is I want to be able to interpret that standard deviation. And whenever we interpret that standard deviation, we say in the long run, we talk about the context will differ from the mean by an average of about blank. Again, fill that blank in. So in the long run, what's the context? The number of goals scored in a soccer game. Will differ from the mean by an average of about 1.3184 goals. Fill in the blank. You guys have kind of learned the importance of these fill in the blank type interpretations. So star it, highlight that. All right, guys, we talked about our probability distribution with discrete random variable. We graphed it, we described it, we just looked at it to talk about different probabilities, so the probability of at least 3. We found the expected value of it, which is the mean. We've interpreted it. We found the standard deviation and interpreted that. Thanks, you guys. I hope you're having a great Thanksgiving break, and we will see you soon.